Welcome to Lesson 8, Graph Transformations and Even and Odd Functions. So this is the lesson where we're really going to start building up our graphing intuition. We are no longer going to be spending our time graphing by just plotting points, making an XY table, picking random values, plugging them in, and plotting those points. No more. We don't want to do that. It doesn't give us a really good idea of what a graph looks like. It's tedious. And instead, we want to build up sort of a toolkit of base graphs, base functions that we know what those graphs look like. And then we're going to apply transformations, ways to change those functions that are based on the equation. Okay. So where we're going to start this process is with what we call the toolkit functions, the base graphs. These are the graphs that you are going to need to know. You need to learn and remember the shapes and the details of these graphs. So I am going to plot point to create these graphs just so that we can get the details of them. But we also already know what some of these look like. For example, y equals x squared is a quadratic, right? It's a parabola whose vertex is 0, 0. So I'm just going to plug in a couple of numbers. All I have to do is square them to get the y and then plot them. So this parabola is going to be at 0, 0 for its vertex. And then the shape of a general parabola is that it goes over 1, 1, 1, and then 2, 4. So it goes up to the 4 on the next one, and then 3, 9, 5, 6, 7, 8, 9. And we can just kind of mirror that on the other side. We've done some work with parabolas, so this particular graph is not new or shocking or amazing. But this is the base graph of parabola of x squared. Y equals x squared, standard parabola, vertex at 0, 0. We need to know that. What about x cubed? So we'll do the same thing. I'm just going to plug in a couple values. I'll cube them. When you cube a negative, it is negative. And so now on the right side, I still have that 1, 1, but then it jumps up to 8. 2, 3, 4, 5, 6, 7, 8. So it's kind of like a parabola here, but a little bit steeper. But then the other side is -1 and -8. So it kind of almost has like a parabola shape facing down type of shape to it. So we talked a little bit in the last lesson about how when a 0 has a multiplicity of 3, it has this sort of bent, curved shape when it crosses the x-axis. And that does come from this cubic function, the y equals x cubed. So again, you need to know what this shape looks like without forcing yourself to create this XY table. So we did it to create it the first time, but now you need to study this graph and know what it looks like. Similar to the square root. Now, I can't put a negative number here for my x because I can't take the square root of a negative number. And in fact, it probably, I mean, I could put down 2, but then I'm going to need to plug that in my calculator and get a decimal, which is not going to help me too much with graphing. So I'm just going to pick the x values I can take the square root of and then try to plot those. I don't think 9 is going to fit on what I have. So I have a 0, 0, 0, 0, 1, 1. Gosh, those are 2 common points. 4, 2, 1, 2, 3, 4, 2. And I don't quite have room. 5, 6, 7, 8, 9 would be up to 3. So this square root function is sort of like a parabola that's laying on its side, but only half of it, right? So if you rotated your paper right now counterclockwise 90 degrees, you'd have half of a parabola opening up. Or I guess if you went clockwise, you'd have half of a parabola opening down. So the square root does look like a parabola, but going sideways, and just one half of it. So again, you need to study the shape of that graph. Now the cube root, just like cubing, you can cube root a negative. So I won't have room for all of these on my graph. But you can think about taking a cube root of these numbers. What number do I multiply by itself 3 times to get -8? It would be -2, etc. Now I'm going to have it run from 1, 2, 3, 4, 5, 6, 7, 8. All right, I'll just put that down here. -1, -1, 0, 0, 1, 1, and 8, 2. So we see kind of a common thread here, similar to that square root, but a little steeper. And it does include, well, that was kind of a messy go over. Sorry about that. And it does include that negative side because I can take the cube root of a negative. Another graph we need to know the shape of. Got a couple more. So y equals 1 over x. This is called the reciprocal function because 1 over a number is the reciprocal of that number. If you don't believe me, start with a whole number. If I were to take its reciprocal, it would be 1 over that number. Start with a fraction. If I were to do 1 over that, that would be 1 divided by that, which would be 1 times the reciprocal. It's a little more work to get there, but it is, in fact, this is just stands for reciprocal. So when you go to put numbers in here, let's try. I'm just going to pick some numbers like that for now. All I'm doing is finding the reciprocal, which is going to be a little bit hard to graph. What happens about 0? Can you take the reciprocal of 0? You can't. This is undefined. Okay. Oops, that didn't really look like undefined. Undefined. So let's start with what I have. I have -5, 1, 2, 3, 4, 5, and something very close to 0. And -3, 1, 2, 3, and something slightly further away from 0. -1. Okay, how about -1, -1? I can plot that. And then we'll do the same thing. I've got 3, 1/3, 5, 1/5, 1, 1. It's not helping me with this graph very much. So let's think about this. I'm going to zoom in a little. Let's think about what this is doing. So if I get a bigger number like -10, well, let me go this way. Let me do it with positives. Like 10, I reciprocal, it's 1/10, 20, 1/20th. So what's happening to this graph is it's just getting closer and closer, whoops, closer and closer to 0, but it's not actually ever going to be 0. It's just going to be a really small fraction, 1/1000th, 1/1,000,000th. Okay. And then what's happening, connecting this here. So we're going to just draw this arrow to kind of indicate that it's getting closer and closer to the x-axis, but never actually touching it. And what's happening here? We know that it's undefined at 0. So what's going to happen in between 0 and 1? Let's say I had 1/2. Well, what's the reciprocal of 1/2? 2. Let's say I had 1/4. What's the reciprocal of 1/4? 4. Say I had 1/100th. What's the reciprocal of 1/100th? 100. So now what's happening is this graph is also getting bigger and bigger, but it's not ever going to actually touch 0. So I think we've talked about asymptotes. We have two asymptotes. Asymptotes. Weird word. And these are lines that a graph approaches. Kind of like forever, but doesn't touch. So right now I have a horizontal asymptote where this graph is going to get closer and closer, but never touch it. And a vertical asymptote. Those are what we did talk about, where it's going to get closer and closer, but never touch it. And if you follow that same logic on the negative side, you'll see that exactly the same thing is going to happen. Going to get closer and closer to the x-axis and then closer and closer to the y-axis. So our graph of 1 over x looks like this. Oh, it doesn't. What did I do wrong on the left side? I forgot to make it negative. Oh, my brain sometimes. Let me try that again. What did I do wrong? Notice how I even wrote them as negatives and then I graphed them as positives. So 1, -1, 1/3, 1/5. Okay. I was in my head thinking of 1 over x squared, which is next. Sorry about that. Better? Let's just double check. We knew these would be negative because the reciprocal of a negative is a negative. 1 over -1 is -1. And then if I add -2, or sorry, -1/2, it'd be -2. -1/4, -4. So we have this below the x-axis, negative numbers. All right, so our y equals 1 over x looks like this. It's in the first quadrant and the third quadrant with these asymptotes. So I kind of gave you the spoiler alert for what 1 over x squared looks like. Again, we cannot plug in 0. And if we do plug in 1, we'll get 1. We plug in -1. This time we will get 1 because I'm squaring. So 1 over -1 squared will just give me 1. So I do have these 2 points. And then just to convince ourselves that that shape is quite similar, if I plugged in 1/2, then I'm going to have 1 over 1/4, which is 4. If I have -1/2, I'm still going to have the same thing because -1/2 squared is +1/4. So I am going to get the same shape. It's technically it's a little steeper than the 1 over x, but it's really hard to draw that in a grid like this. So I know I messed up the last one and fixed it at the last minute because I looked at it and said, that's not the graph of 1 over x. That's the graph of 1 over x squared. Okay. So they are similar. 1 over x is here and here in the first and third quadrants, but because the 1 over x squared has the squared in it, it kicks the negatives up to the positives. And one more graph that we're going to use as our base graph that we'll have to know about is the absolute value of x. And remember, absolute value just makes everything positive. So if you're plugging in a negative, it's going to be a positive. If you're plugging a positive, it's just going to be itself. And so that what that ends up looking like is actually a straight line on the right side and another straight line on the left side that connect at that 0, 0. So it's basically a V. What's kind of the same idea as a parabola, only the shape is straight lines. Whoopsies, I didn't mean to do that either. Straight lines. And that shape is a V with a sharper point right there at the what would kind of be like the vertex.